Okay, welcome back, everybody. We're about to start a new chapter, and this chapter focuses on area of different shapes. In particular, today we are looking at the area of a triangle, parallelogram, and trapezoid. We've studied all these shapes before, but now we're taking a closer look at the area. So my goal is to show you kind of where these area formulas come from. I've just been telling you, but they do come from places. They're not just made up. And so we'll do some explanations and work some examples on that. First, we'll start with a parallelogram. So you've probably seen an area of a parallelogram as base times height, but where does that really come from? So in the screen there, you see on the left side a picture of a parallelogram in black. What if I took cut off a little corner here? Let me get the pointer out. Cut off this little triangle on the left side here. Just taped it over here on the other side of the parallelogram. If I did that, then you'd see this rectangle here, like you see on the right. Well, we know the area of a rectangle is base times height. So since we didn't really destroy any area when we cut that triangle off because we put it on the other side, that parallelogram is going to have the same area of that rectangle, which is base times height. So just like the area of a rectangle is base times height, so is the area of a parallelogram base times height. All right, so let's do an example of that. Should be pretty simple. Example number 1. So I got to find the area of that parallelogram. So again, we know that the area of that parallelogram is base times height. So the base is 6. And the height we don't know. But if you're looking at that right triangle there, you got a Pythagorean triples here. You got 3, 4, 5. 3, 4, 5. So there's where your Pythagorean triples came in handy. So we're going to replace this side of the triangle here with 4. And notice that is also the height of the parallelogram. So we got 6 times 4 base times height. And we do have units here, so it's 24 square inches. Okay, so there you go, area of a parallelogram base times height. Next up is the triangle. I've told you all year that the area of a triangle is 1/2 times base times height, but I never really told you where that came from. It actually comes from somewhere. Imagine that you have this black triangle here, and its base is small b and its height is h. And let's say we just made a copy of that triangle, like you see the red one there, and stuck it right on there. So if you take two congruent triangles and fit them together, they will form a parallelogram. Well, how do we know that? Both pairs of opposite sides are congruent, right? Top and bottom are doubly marked. Left and right sides are singly marked. So we had that theorem. It goes back quite a ways. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So that's a parallelogram. So we know that parallelogram's area is base times height. We just looked at that. And since the black triangle is actually what we're looking at, the area of that black triangle is half of that parallelogram, so its area is 1/2 times base times height. So the area of a triangle is 1/2 the area of a parallelogram, 1/2 of base times height. Let's do an example for that. So we're going to find the area of that triangle. So we know that the base and the height have to be perpendicular. So we're going to have to find that base down there so that we can put that into our area formula, because we know the area is 1/2 times base times height. All right, so I'm going to do a little Pythagorean theorem. I'm going to replace that b there. So it looks like we got 12 squared plus, I'll call that x right there. That's x. X squared equals 20 squared. And I believe these are actually Pythagorean triples that we don't see very often. So 144 plus x squared is equal to 400. X squared is equal to, that should be 256. And the square root of 256 is 16. All right, so now we know that this leg of the triangle is 16. All right. So that's going to be our base. And so the area of this triangle is 1/2 times the base, which we just found to be 16, times the height, which is 12. And so the area of this triangle is going to be 96, I believe that, isn't it? 96 square meters. So 96 square meters. Okay, area of a triangle, 1/2 times base times height. We already knew that, but now you know where it comes from. Finally is the area of the trapezoid. We remember that trapezoid is a four-sided figure, so it's a quadrilateral with one pair of parallel sides. And so just like in the previous situation, if you take two congruent trapezoids and fit them together, you're going to make up a parallelogram. So if I take this black trapezoid and make a copy of it and turn it upside down and stick it up against this first one we had, then you got a shape there, which is a quadrilateral. Well, why is it a parallelogram? Where these two sides were congruent. So there's one pair of opposite sides congruent. Then if you add the bases, the base 1 and base 2 on the top, that's going to be the same length as base 1 plus base 2 on the bottom. So you have two pairs of opposite sides congruent for a quadrilateral, so that makes that a parallelogram. So if you calculated the area of this parallelogram, it's just base times height like we saw earlier. Well, the base of this, I'm talking about the big parallelogram now, the whole thing, its base is b sub 1 plus b sub 2, makes up its total base, and its height is h. So the height of that parallelogram is h times the sum of b sub 1 and b sub 2. But remember, to get that parallelogram, we had to double the area of a trapezoid, the black one. And so it would make sense that the black trapezoid area is 1/2 of the total parallelogram area. So you take 1/2 of h times the sum of the bases, that is the area of a trapezoid. So the area of a trapezoid is 1/2 times the height times the sum of the bases. Okay. And finally, let's do an example for that. And then you're going to get a bunch of practice working, calculating areas. All right, so we have, it's easy to calculate an area once you have the formula. So it just says find the area of the trapezoid. So area is 1/2 times the height, which was 3, times the sum of the bases, so 9 plus 12. Okay, so we can do this. So let's see, you can do this in any order that you want. So I'm going to have 1/2 times 3. This is going to be what, 21? Oops, I wrote it 1/3 there. I wanted 1/2. 1/2 times 3 times 21. And you can do that in your calculator. That's just going to be 63 divided by 2, right? Because you're multiplying by 1/2. So 63 divided by 2 is going to give you 31.5. And remember, when you're talking about area, you're talking about square units. So this is going to have to be square centimeters. Okay, so that's it. Again, to calculate areas, you just need a formula. And I just wanted to point out that the formulas come from somewhere. They're not just drawn out of thin air. And the three that we need for today are area of a parallelogram, base times height. Area of a triangle is 1/2 of that. So area of a triangle is 1/2 times base times height. And finally, the area of a trapezoid is 1/2 times its height times the sum of its bases. Okay, there you go. That's what you need to know. Let's go ahead and get some practice on the assignment. Good luck.